What level you work
Okay,
with?
we're gonna go ahead and start, all right? All right,
Yeah, you could get it done.
so for the first one here, iodine reacting with sodium fluoride. What are your expected products?
Oh, no reaction,
There's no reaction.
no reaction.
Why would she say no reaction?
Because fluorine is on the top of the reactivity series. And iodine's at the bottom.
Correct. Yeah. So what she said is because fluorine is at the top of the activity series, iodine will not be able to displace fluorine or fluoride. Therefore, in this case, there's no reaction. You don't have any products formed. Now, if you had switched this to F2 reacts with sodium iodide, because fluorine is more reactive or more active than iodine, then it's going to displace the halogen iodide, and you're going to form sodium fluoride and I2. Okay, so again, so when you look at your periodic table, the right side, fluorine's at the top, that's the most active, and then it decreases as you go down. So that's something to keep in mind, the activity series of the halogens. Okay.
Will that be given to us on the test activity series?
You'll be given a periodic table, so if you know the trend,
Okay.
if you know like fluorine is the most active out of all the halogens, then you should know, like if fluorine is more active than bromine, bromine is more active than iodine. All right, go ahead and predict the following products. Oh, before we get into this, can I ask where y'all are in class? What have y'all been, what did y'all learn today?
Oh, gas laws.
Gas law.
Okay, so you finally
We're
got.
about to do
We're about to-
Rose law, the ideal gas law,
Like,
just started, that was a video that's due tomorrow on.
Okay, perfect.
Yeah.
Awesome. You can start getting into that stuff. Probably Friday. Who wants to predict the products for A? Not you.
So you get potassium chloride, which is soluble, and then you get calcium phosphate, calcium phosphate, which is not soluble.
And then she said CA3. And how did you know that this was the type of reaction? These were the products.
It's a double displacement, so the cations are gonna replace each other and the anions replace each other.
Yeah, so if you didn't hear her on Zoom, is she recognized that since you have two ionic compounds here, you have each one has a cation, each one has an anion. It's going to be a double displacement reaction where the cation of one is going to displace the cation of the other. So in this case, potassium is going to displace calcium, and it's going to be potassium chloride. And then calcium will displace potassium, and it'll get calcium phosphate. And you want to balance these. You do so like. So if I put 2 there, 6 here. And then 3 there. Yeah. Okay, so that's how you would balance it. But I'm not going to go into the balancing part just because something you already know how to do, right? What about the second one? Same thing, right? You see two ionic compounds. And they're going to, it's going to be a double displacement reaction. So what's the first product? KNO3. Is that soluble or insoluble? And how do we know it's soluble? Perfect. And what about the second product? And we recognize that it's lead with a 2+ charge, right? Because when we do the reverse crisscross, the 2 comes up to the lead over here. And is this soluble or insoluble? So it's gonna be insoluble, thus this is a precipitation reaction. And what about, let's go do these up here. We already said potassium chloride is aqueous. What about calcium phosphate? Calcium is not in the first group.
Calcium is a group 2, and phosphates are only soluble with group 1 or ammonium. So it's a solid.
There we go. She said phosphates are generally insoluble. The only exceptions would be group 1 elements and ammonium. Okay. And what about C?
No reaction.
And why do you say that?
Because because the acetate is always soluble, and then
So you're saying these are the products. CH3. In CH3. So those are the products, right? But if you were to write out your net ionic equation, everything cancels out. Therefore, yes, no reaction occurs in this one. But I didn't say that in this. I just said predict the products. If you were asked to predict the products on an exam, it would be multiple choice, right? So you would be given either, if you see no reaction, then yeah, that's the answer. But odds are you probably just say these are the products. Okay. But yes, if you were to write out the net ionic equation, you would realize that no reaction actually occurs. And what about D?
NaNO3
That's soluble or insoluble?
soluble.
And
Silver chloride.
AgCl. And we know that chlorides, halides in general are generally soluble. And what are the exceptions?
Silver, mercury, and copper.
Copper, which one? Copper 1, right? Copper +1. So this is soluble. I'm sorry, solid. It precipitates. And what happened? What about when you react nitrogen with 3 hydrogens? It's just what kind of reaction is this? Synthesis, right? And you get NH3. And the reason I know it's NH3, not N2H4 or anything, because this is how you would balance. It would take, these are the coefficients that I'm giving you. You don't want to change these, okay? So you would have to change these a little bit in order to balance this out. Okay, so thus the product is ammonia. And lastly, calcium carbonate reacting with heat. Yeah.
Oxide and carbon dioxide.
This is something we saw in class, I believe, yeah. So calcium oxide is produced and then carbon dioxide. What is carbon dioxide? Is that going to be aqueous, solid, liquid, gas? Okay, yep. And calcium oxide. Is that going to be aqueous? It's a solid. It's forming a salt.
Could you go over this one? We
Yeah.
never saw this.
Yeah, so this is something Dr. Armand went up, I think it was on one of his quizzes or something. It was just when the carbonates react with heat, they generally form salts, oxides, and then carbon dioxide.
Only with carbonates?
Carbonates, yes, but when you have like acid-base reactions, with bicarbonates or carbonates, that's when you form your H2 gas, a salt, and then carbon dioxide. So we're gonna have that whole. So acid,
Is it always heat? Is heat always a reactant? Like it'll say heat?
yeah, so we put it on the reactant side, but sometimes it looks like this. Where you have, it'll say heat here or something. But it's the same thing. You have to add heat to the reactants. So again, that's when you have a carbonate, a salt that has the carbonate anion reacting with heat. You're going to form an oxide of the cation and then carbon dioxide gas. Okay. Those are just some general reactions that we have to memorize. There's no way really around it. I did want to give a brief review because one of the things people said they couldn't distinguish was different types of electrolytes. So it's going to be very brief. I know some of y'all might not need this, but strong electrolytes are things that dissociate completely, right? So 100% of the time. So complete. So and that's 100% of the time. And that includes what?
Strong acids, strong base, soluble salts.
Strong acids, I'm gonna abbreviate SA. What are the strong acids? What? I hear. Okay, I'm just gonna start writing it down. HNO3, H2SO4, HCl4, and then your halides, except for hydrofluoric acid, so HCl, HBr, and then HI. And strong bases include what?
Sodium, sodium.
So group 1 metals, and then we have calcium, strontium, barium that are bonded to what? Hydroxide. Okay, so that's something like sodium hydroxide, potassium hydroxide, calcium hydroxide, which is CaOH2. Fix that a little bit. Right? And then what's the last thing that are strong electrolytes? Yeah, so salts that are soluble, right? Yeah.
So I read somewhere that oxides are also strong bases. Is that something Dr. Armand's going to test us on?
Not in Gen Chem 1, but it's good to know that when you get to a later class, like OChem, that like methoxide, which is CHO-. This is a really strong base that can deprotonate an acid or anything with the acidic proton. But yes, that's true, but you don't need to know that for this part, okay? That's a salt. And so that's anything that is can dissolve in water, right? So you have your group 1 elements, which always dissolve. Your nitrates, acetates, and ammoniums. Anything with those are going to be strong soluble salts. And then there's obviously other things like sulfate. Usually is considered a soluble salt, but it has an exceptions that will make it a non-electrolyte, right? Something that won't dissolve. And let's jump down to non-electrolytes. I just said that a non-electrolyte is something that does not dissociate or is an insoluble salt, okay? Salt, I cannot spell that. Okay. And that's something, basically everything that is an exception plus, okay, so like silver chloride, right? That's a salt. We know chlorides are generally soluble, but when bonded to silver, it's not, right? So that's an insoluble salt. And that's a non-electrolyte because it does not dissociate. Something like calcium sulfate. Sulfates are generally soluble, but when bonded to calcium, strontium, barium, they're going to be, and some other ones, they're going to be insoluble. And what else is considered a non-electrolyte? Not necessarily. Because a weak electrolyte is weak acids, weak bases. A weak base example is a covalent compound, ammonia. Ammonia has this lone pair that is able to extract a proton. Therefore, it's a weak base, which is why it's considered a weak electrolyte. But it is a covalent compound. So non-electrolytes are things that don't dissociate. So like
Carbohydrates.
carbohydrates, so like glucose, right? So C6H6 or H12O6. There's anything that doesn't dissociate when thrown in water. What? Okay. The last thing, or there's a couple more things I want to do. Let's write out the molecular equation and then the anionic equation for the following reaction. What is the formula for plumbous nitrate? You knew that because plumbous is the lower charge and lead can either be +2 or +4, so it's +2. And that's aqueous. Reacts with barium sulfate. Let's change that up because that would not work. Let's do. Yeah. Because barium sulfate is insoluble, right? So this would not be a reaction. So I need to think of something else. Let's just do sodium sulfate. So Na2SO4. And that is aqueous. The products that are formed are what?
Lead sulfate and sodium nitrate.
And what are the physical states on these?
Solid lead sulfate and aqueous for the sodium nitrate.
And that's an exception, right, to the sulfates. Lead 2+ will make sulfates insulated. Then aqueous. What I'd like to do, but I think first we should balance the equation, right? So I'm gonna put a 2 here, and that'll balance everything. Yeah. Okay. So the easiest thing for doing these types of problems are going to be just find your precipitate, and that's that and everything in it is going to be in the net ionic equation. So you don't have to write out the whole thing and do your canceling out. If you know that everything on the left side is aqueous, but everything on the right side besides lead and sulfate is aqueous. So lead and sulfate are going to be the only things in your net ionic equation because they don't cancel out, right? Because on the right they're in their solid form, on the left they're in their aqueous form. So on the left it would be Pb2 plus aqueous plus your SO4 2 minus aqueous gives us PbSO4 solid. Okay. And that's really the fastest way to get through these problems. Sometimes I look at people's exams and I see them write out the whole thing, but they don't have to. As long as you see which one is the precipitate, go look at your answer choices and see which one has everything in the reactants that is the precipitate, and then the only thing in the product should be the precipitate as well. I think there's a problem like that somewhere later. I'll show you. Okay. Now, yeah.
So this would always be
Yeah, that's correct, because everything, in order for this to happen, a reaction has to occur, right? So a precipitate must form, because if not, then no reaction occurs, right? If everything's aqueous, no reaction occurs, right? So in your net ionic equation, the precipitate has to be in the net ionic equation, and therefore everything that the precipitate is composed of on the left side of the equation has to be in its ions, right? But everything that's soluble on the right side and the left side, you should know that's not going to be in the net ionic equation. So you don't have to do the whole canceling out thing, okay? It'll save you some time. Okay, so what's being oxidized and what's being reduced, and then what's the oxidizing agent and what's the reducing agent? for the A. Let's assign oxidation numbers for the first part. What's the oxidation on iron here? 0. What about oxygen? 0. And we know this is ionic, so the oxidation numbers are the same thing as their ionic charges. So iron has a charge of what in this case? That's 3. Oxygen we know is -2. Well, what's being oxidized? Which one? Yes. So iron is oxidized
So reducing agent.
because it's losing electrons, right? The plus charge means it's giving away its electrons. And that therefore oxygen is being reduced. And what is the oxidizing agent? O2, right? So I'm just going to abbreviate this OA. And this is going to be O2. Remember, the agents can only be reactants. And you can't say that oxygen, just O by itself, is the oxidizing agent. You have to say that O2 is the oxidizing agent. And therefore, the other reactant, reducing agent, would be iron. How about, I'll give you all a second to assign oxidation numbers to everything in part B, and then we'll see if y'all were any close, or maybe we can touch on that. Yeah, just this part right here. Yeah, so remember what the oxidizing agent, the definition of an oxidizing agent is something that is facilitating the oxidation of something else, right? Therefore, in itself is being reduced, because in order for me to be reduced, I have to tell you to give me something, right? So say we're just talking about money. If I'm the one gaining money, I'm being reduced. I'm the oxidizing agent because you're the one that's being oxidized and losing the money, right? But I'm facilitating the oxidation by, hey, you give me all the money you got, man. Okay. Yeah, give me all the money. Does that make sense? Yeah. So the one that's oxidized, it's kind of, people kind of get it confused because the one that's oxidized is usually the reactant is the reducing agent, and the one that's reduced is the reactant is the oxidizing agent. Kind of flip that. All right. What's on the left side here? What's the oxidation number for chromium? +6. And we all know how we got that. Head nods? No? Yes? I can go over it if y'all don't know. Okay, perfect. And what about oxygen? -2. And what about the other oxygen? -2. And then +1 on hydrogen, right? And what about the chromium here on the right? +6 again. Oxygen's -2. +1 and -2. What's the oxidizing agent? Or what's being oxidized here?
It's not redox.
So there's no reducing agent or oxidizing? Okay, yeah, so this isn't what we would say is not say it with your chest, not a redox reaction, right? So this is not a redox reaction. Okay, what about this? Yeah.
Why is it not a redox reaction?
Why is it not a redox reaction? Good question. Okay, so in order for it to be a redox reaction, oxidation numbers of any element, or specifically any two elements, because in order for one thing to be oxidized, that means another thing has to be reduced, right? And vice versa. So the oxidation numbers have to change for within the reaction. So like we see here on the left side, chromium is a +6, right? We know how we got that, right? Okay. And on the right side, it's +6. So it remains the same. It's not being oxidized. It's not being reduced. So we go to the next element. Oxygen is a -2 here. It's a -2 here. It's a -2 here on the right side. And it's a -2 here. Therefore, it's not being oxidized or it's not being reduced because that number is not changing. Okay. Now, let's say chromium, let's just say hypothetically chromium went from a +6 to a +4. I'm just gonna ask this person, no one else in the front row wearing a purple sweater, say anything, okay? Is chromium being oxidized or reduced in this scenario?
Oxidation as a loss of electrons, it's reduced.
I was asking,
Oh, I'm so sorry. Sorry.
okay,
She
so-
said it also.
we're going from a more positive number to a less positive number, right? And we know electrons carry a negative charge, right? So therefore, this chromium is actually gaining 2 electrons, which bring it down from a +6 to a +4. So if it's gaining electrons, it's being what? Reduced, right? Because we know our little acronym, oil rig. Not the Leo the Lion goes Girder, not that one. This was oil rig. Oxidation, it's losing electrons. Reduction, it's gaining electrons. So we said chromium's going from a +6 to a +4. It's getting more negative, right? If it's getting more negative, then it's gaining electrons. Therefore, it's reduced. Now, if it was chromium 3+ going to chromium +6, we're getting more positive. Therefore, electrons carry negative charge. So if we're getting more positive, we're losing more negative charge, right? So we're losing electrons. Therefore, in this case, it's being what? Oxidized. Does that make sense? Okay, that was a good question. Again, this is a concept a lot of people, it just doesn't settle in the brain as easily as other things. Whether that press. No. Okay, we're good. Next one. Let's assign our oxidation numbers. What's the oxidation number on nitrogen? So this is a little tricky. What I like to do is I like to break it up into its ions. So it helps me to see NH4 plus and NO2 minus. Okay. So on the left side, each hydrogen is going to be +1, right? So that's a total of +4. And we have an overall +1 charge, which means the nitrogen has to be -4, because remember each hydrogen has a +1 charge, and we have a total of 4 of them.
Oh, -3.
Correct, yeah. So we want an overall +1 charge. So if we have +4 from the hydrogens, then we have to have a -3, which will give us our overall +1 charge, right? So in this case, -3 +1. And what about on the nitrite? Say it with your chest.
+3.
Okay, plus, I can't hear you.
You don't answer, so.
Yeah, you're right. You shouldn't answer.
Yeah.
I'm just kidding. Feel free to answer. Except when I say I'm specifically talking to one person. Okay, on the right side, what is nitrogen? How do we know it's 0? Let me ask, is it okay if I pick on you in the back again? Just because I want to make sure we're all getting this right. So they said it's 0, but how do we know it's 0?
Because nitrogen is a diatomic atom, meaning that when it has like 2,
Yeah.
it's completely filled.
Correct. So when it's any element is in their natural state, nitrogen being diatomic, so N2 is in its natural state, has an oxidation number of 0. That's a perfect explanation. Thank you. What about, we already know oxygen's -2, hydrogen's +1 in water. That's just something you'll memorize as you do problems like this. this is a redox reaction or not a redox reaction?
Only one of them's changing, but I don't.
They cancel each other out.
I don't.
I don't think so. Like, if you add.
Okay, so. You really have here NH4 plus NO2, I guess. At the end of the day, these are both different atoms. Like in a reaction, you have these nitrogens reacting with these nitrogens, right? This one's going from a +3. This one's going from -3, both to a 0. So you still have, it is a redox reaction because you have one. Okay, this -3 here, is it gonna, if it's going from -3 to 0, is that being oxidized or reduced?
Oxidized.
Oxidized, right? Now this one here on the nitride, it's going from a +3 to a 0, being reduced, right? So again, you have different nitrogen in this reaction.
So two separate.
In this case, then would the oxidizing agent and reducing agent just be ammonium nitrate?
Ammonium, that's correct, yeah. So the oxidizing agent and the reducing agent are this one reaction here. So oxidizing agent plus reducing agent are the same thing because we only have one reactant, right? And it's NH4 NO2. Okay. Yeah,
Like, I don't know if it's possible, but like, if it was insoluble, like I know with ammonia, it can only be soluble, but if it was insoluble and there was two different elements, then would we not consider it redox?
I'll do some research on that. I've only ever seen it like with something. I mean, it gives you the reaction and then it asks you if this redox or not. So clearly, I don't think they would give you a reaction like this and say, is this redox or not? And then you would have to say, oh, well, actually, this reaction is wrong. So no, just go about the numbers. If the numbers change, you can see which one, you can see that it's a redox reaction. Okay. But yeah, I see what you're
So it doesn't
saying.
have to do with the fact that it's soluble then. Cause then like,
I don't think so, because that's usually when you have like one salt reacting with another salt in the aqueous solution. This is probably happening under a lot of heat or something, if I guess, like you take a salt and then you just blast it with heat and you form nitrogen gas and water. If I had to guess, I'm not sure. What about this one here? This looks like something I saw in Sadeghi's lab. So what is the chromium is by itself, right? So it's in its natural state, right?
No,
Oh, I'm wrong.
that,
Wrong.
yeah.
So what's the oxidation number?
Three.
That's 3, right?
Wait,
That's
what's
pretty.
chromium's natural state?
Zero.
Zero.
He's trying to trick you.
If chromium's a
If it was
catalyst.
chromium just by itself, it's a solid, right? They can also help you out by putting solid because chromium is a metal, right? So therefore, this would have an oxidation number of 0. But it's not chromium. It has a charge, right? And that charge tells us automatically the oxidation number. +3. What is the charges for H and O in water?
It's two on. It's plus when you have minus, I think.
Yeah, it's 2, right? That's just, we've seen that like 3 times already.
It's plus five. Chlorine is plus one.
So we know oxygens are -2. We have 3 of them. And this is equal to an overall -1 charge. And we have 1 chlorine. You'll get Cl -6 equals -1. And you get Cl equals +5 when you solve for it, right? So +5. And the oxygens are -2. On the right side, what is the chromium in this case? Plus 6. And then -2. What about the chlorine here? Plus 4. -2 again. And then what's the oxidation number for hydrogen in its natural state in this case? In its natural state. It's not in its natural state, it's H plus, it's a proton. Okay. What's changing? Let's highlight what's changing. What's changing from the left side to the right side? Let's go from left to right. Chromium, is that changing?
Yeah.
All right, that's something to, ooh, that's big. That's something to take into account. We'll look at that. What about hydrogen? Oxygens? Chlorines? Yeah, +5, +4. So chromium is going from a +3 oxidation state to a +6 oxidation state. Is that being oxidized or reduced? Oxidized. Chlorine's going from a +5. Okay, nothing in the chat. I haven't been paying attention. Okay. Chlorine's going from +5 to a what? +4. That being oxidized or reduced? Reduced, right? It's getting close, it's getting more negative, right? Closer to negative numbers, if you will. Therefore, it's gaining electrons. So it's reduced. That tells me that that tells me what about what are the oxidizing and reducing agents?
Reducing agents are,
Oxidizing agent is
Or can you speak up?
the reducing agent is chromium and the oxidizing agent.
So. Reducing agent is Cr3 plus, and we can say that because that's actually a reactant, right? And then oxidizing agent would be what? Chlorate. How do y'all feel about these types of problems? Good.
Yeah, that helps.
These are, you're definitely going to see a few of these problems on your exam. We'll do that later. Worksheet. And then the last thing I want to do is this quick quiz. Let's see, man. Yeah, it requires a bit of brain power, right? Just to get more practice. I'm going to be sending out a review later, and I think we're going to do it as we go throughout the weeks, just because that review has like 50 questions on it. So last semester, I just gave it to them and did it to them. I'm sorry, I gave it to them and then hope they did it. But I'm gonna actually go through it with y'all so you can ask questions. And so
Where are you sending it?
I'm gonna send it over email.
Okay.
But I'm thinking, because I don't know if I want to give you all 50 questions at a time. I might just give you like, hey, Monday, we're gonna go over 1 through 8, and then we'll go through 1 through 8. Yeah.
I know you said you can't like post the videos because of how big the file is, but maybe like the finished like worked out sheet.
Yeah.
So that way, like, even though we can't see the video, we can still kind of see what you did.
Yeah, definitely. And I do have the whole answer key already. But the problem with that is that last semester, people would do the problem, they would get stuck. They would look at the answer key and be like, oh, okay. And then they would go about the problem, right? But that's not how you are gonna learn anything. You should not have an answer key. But if you work out the problems, show me, you can, come to my Wednesday sessions. Say, look, I worked out all the problems. I'll send you the key then. But I don't want to hand out the key first like I did last semester, because then people, every time they get stuck, they look at the answer key and they're not going to learn that way. Because on the test, if you get stuck, you can't learn to look at an answer key, right? So I think you actually genuinely have to train yourself on how to solve these problems, and you'll get better at it that way. If I just give you an answer key. Some people actually did it the way I recommended them to. Other people, as soon as they get stuck, look at the answer. But yeah, this is 5 questions. Oh, yes. And yeah, I'll send that. Yeah. I'll send that out over email. eventually when I decide to go start going over those problems. How fast can we answer all these questions? What's the answer to number one? Right off the bat, I'm looking for something that's generally insoluble. So I see, look at A, I look at all of them and they're like, no, those are all going to be soluble no matter what. I look at B, I see a hydroxide. I know that's going to bond to the other cation, which is iron. That automatically makes iron hydroxide, which we know is insoluble. If you keep going further, you see that silver bonds to acetate, no, nitrate, always soluble. This makes H2O and NaCl is an acid-base reaction. And then ammonium hydroxide and HCl make ammonium chloride and H2O liquid. So no precipitates are formed in either of those. Okay. What about this one? And yeah, so what I would notice first, if I was on an exam, I would say, okay, this is going to go to that, that's going to go to this, cross that out, AgI is insoluble. I'm going to cross out anything that does not have AgI alone in its net ionic equation. So A, B, D, E, I double check C, that's the net ionic equation I'm looking for because these are solid. That means on the left side, they had to be aqueous, C. On the test, you try to go as fast as you can. At least I try to go as fast as I can. So I have like an hour to review all my questions, okay?
Like, would that like be for the final? Like, was the final like a time crunch, would you say?
I don't know, I was like really sick on the final.
Oh,
So you're just deliriously doing it.
Yeah, I finished with like 20 minutes left, but I was like, I'm not gonna review 70 questions. That's too many. Okay. How many grams of phosphoric acid are in 175 milliliters of 3.5 molar solution of phosphoric acid? I see this, the first thing that comes to my mind on a test is molarity equation. That'll give me the moles. From moles, I can go to, using molar mass, I can go to grams, right? That's my thought process. So immediately I'm saying 3.5 times the liters. I convert it in my head. I'm doing all this in my head on the test. Is equal to, and I punch it into my calculator. What was it?
I know, it's so sad.
I got
0.6125.
20, I'm sorry, 0.175 equal, yeah, so 0.6125 moles. And then from there, I'm gonna find the molar mass. So we know phosphorus is what?
30.97.
30.97 plus 64 plus 3. 30.97 plus 64 plus 3. 97.97. I'm going to multiply that by the moles, right? Because you want to cancel out. So I'll bring it down here so you can see what I'm doing. 2.5 moles. We want moles to cancel out. So 1 mole equals 97.97
We had to do this.
grams. And times 0.615, I get an answer of 60 grams, which is A. And then how many moles of barium chloride are formed in a neutralization reaction of 393 milliliters of 0.17 molar barium hydroxide solution with aqueous HCl? That was a mouthful, right? Okay, first thing I see is moles of BaCl are formed in a neutralization reaction. I'm going to write out my equation. So we have BaOH. Yeah.
So it's volume equals moles over molarity, right?
It's molarity. I mean, yes, but
Or is it
I do
molarity
molarity
over
equals,
moles?
I do molarity equals moles divided by liters.
Oh, okay.
But if you can say liters equals moles over molarity, it's just a
So
rearranged.
molarity is moles over liter. Okay.
And then HCl. I know that this is, since this is a monoprotic acid and this is a base that has 2 hydroxides, it's going to be in a 2-to-1 ratio. So I already know I'm going to have to put the 2 there. I'm going to put barium hydroxide, or no, barium chloride, and then H2O. So let's see if we have to put that there, and it's balanced already. So that's our mole to mole ratios, right? That's our balanced chemical equation. I'm gonna find moles of barium hydroxide converted to, yeah, with aqueous HCO. See how many moles of these are formed in fluidation? Okay, so in this case, it looks like HCl is excess. So I'm gonna find the moles of BaOH2, convert that to moles of BaCl2. But we notice that there's a 1-to-1 ratio here. So therefore, moles of BaOH2 is equal to the moles of BaCl2, right? So we're gonna do 0.393 liters times 0.171 molar equal 0.393 times 0.171, 0.067 moles, which is again, you may not be as quick with this as I am. I'm just trying to show y'all what's going on in my head when I see this on an exam. All right. And just maybe you can see like, maybe I should go a little faster so I have more time to review. Because honestly, when I review my exam questions, I noticed that I missed like 2 questions and I fixed it. You know, if you don't give yourself time to review, then you won't be able to catch your little mistakes or something. Okay. So try not to stay on a problem for more than 30 minutes, if possible. Some of them take longer than 3 minutes, I know that. What mass of grams of silver bromide is formed when 35 milliliters of 0.184 silver nitrate is treated with an excess aqueous hydrobromic acid? Okay. This looks like 1-to-1 ratio. I'll write out the equation for you, but everything in this has a -1 charge. So HENO3 plus HBr going to give us AgBr HNO3. And from here, everything is balanced already. So we're gonna find the moles of, what is that, HENO3. And we know that since it's a 1-to-1 ratio, that's equal to the moles of AgBr. So 0.0355 liters times 0.184. And then now we need to multiply this number, 6.532 10 to the -3 moles of AgBr. AgNO3, which is equal to the moles of AgBr. And again, I got this number from I converted it to liters and then multiplied it by that, okay? And we're gonna multiply that by the molar mass of AgBr, which is pretty large, right? So times silver is 107.86 plus 79 gram, 79.9. Someone says this periodic table, yeah, or things just like this. So I get an answer of 1.23. Okay, that's all I have today. There is a class in here and like. Please scan this QR code accordingly so I can track y'all's data in the next exam. I see 10 people, or I see 8 people on Zoom and like at least 1 person in here. So I should expect at least 9 people responses today. They're recording.
Oh,
Did
They're
we can't
recording.
scan it because of the thing.
Oh, okay, give me a second. Let me go ahead and go to this one.
works.
Try that one. Yeah, so I should at least have 9 responses because there's 8 people on Zoom and at least 1 person in here, right? Sam, go ahead and scan it for attendance. But yeah, any questions on anything? Please make sure y'all put what y'all are struggling on in that so we can make a worksheet for Friday.
Everything in general.
Okay, don't say that. When people say everything, I'm like, oh, come on, like,
Well, seriously.
No,
you're
but
struggling
seriously,
with
I did not do
everything.
good on the last
It's
exam and
like-
half of it was pure guessing.
okay, but I can't go over everything in my sessions. you
No,
know? I have to
obviously.
act- Yeah, I have to like tailor it to what people are struggling on the most. So when you say,
Sure.
when you say everything, that could be balancing chemical equations, you know, so
Sure, yeah.
are you struggling with balancing? chemical equations?
I'm struggling on writing chemical equations.
So like predicting products.
No, it's just like, no, I don't even know. Like, you'll give me like, green, like, if it's sodium sulfate, I won't even know like how to write that out in like the compound name.
Oh, so you don't know how to go for the name. Well,
Yeah, yeah,
you might want to work on YouTube,
I was trying to.
practice, get more practice.
I've been practicing. It's still not.
Okay, I have a question about.
Yeah. Yeah, since we finished chapter 4, can we please look at chapter 4? So you mean like, yeah, I can make one if I have time. You're basically meaning to like, major kind of,
You go, I don't know.
like that's stuff in the last few questions.
It's really.
Even.
Like, I'm just scared that.